Hello again. I'm still Andrija Krtalic and I came from the University of Zagreb, Faculty of Geodesy, and in this session I will introduce you to the electromagnetic spectrum. I will start this session by defining the physical term radiation. Radiation is the amount of incoming energy emitted by any source and any wavelength which falls on unit of surface. If the source of radiation is the sun, such radiation is called solar radiation or insolation. Insolation contains the full spectrum of electromagnetic radiation. The carrier of radiation energy is the photon. Photon is the smallest particle of radiation, respectively quantum of the electromagnetic field. Photons do not move in a straight line through space, but oscillate around the direction of propagation. Therefore, their trajectories are wavy lines, wavelengths, and electromagnetic spectrum travels in wavelengths. It can be said that photons surf on wavelengths. These waves cover a wide spectrum from the smallest cosmic rays, so-called gamma rays, to the longest radio waves. The human eye is sensitized only to a narrow part of the spectrum, from the so-called blue to the red part. People use the part of the spectrum to observe their surroundings. Radiation energy moves through the space in two vertical planes, one called the magnetic field and other electric field. We can imagine photons surfing on different waves, thus moving through the space. Because the electromagnetic spectrum can be observed through the movement of photons and the propagation of waves, it says to the dual nature. All those photons surfing at all wavelengths create incoherent light. The wavelength of the electromagnetic spectrum used in remote sensing are shown on this slide. The reflected energy of photons surfing at wavelength up to 3 micrometers is used to create image of object in the visible and near-infrared range of the spectrum. To create thermal images, the emitted energy of objects radiating wavelengths longer than 3 micrometers are used. Microwave use the reflection of photons to create radar images. All objects reflect radiation emitted by a source. Likewise, all objects emit electromagnetic radiation which they have previously absorbed. By recording and analyzing reflected or emitted radiation, experts in remote sensing gain knowledge about the characteristic of objects, classes, on the scene. The main 4 classes on the Earth's surface are water, vegetation, natural object and object build-up object or artificial object. All objects differ in the way they reflected or emitted radiation. Light reflects off object and travels to the human eye. Light passes through the cornea into the pupil and through the lens. The cornea and lens reflect the light to focus on the retina. Photoreceptors on the retina convert the light into electrical impulse. The electrical impulse passes along the optic nerve to the brain. The brain processes the signal to create an image. So, people see with the brain, and eyes are just sensors that receive the stimulus and send it to the brain. Scientists and experts study nature and try to copy it in many fields. For example, the shape of bird's wing has been used to produce airplane wing, while artificial intelligence tries to simulate the working of the brain. This is how sensors were created, simulated the human eye and produce image of reality. On this slide, you can see the digital image creation process and the range of pixel values that make up the object, house, or some other object. Each object reflects the spectrum differently, and this is articulated on the imagery with a different shade of grade value or a different color. This is called the spectral signature of that object, but we will talk about that in the next presentation. The area below the blue line on this slide indicates the amount of electromagnetic radiation in a vacuum outside the atmosphere, and the area below the yellow line indicates the amount of electromagnetic radiation in the atmosphere. The difference in energy is absorbed by the atmosphere, and this energy, these photons, never reach the surface of the Earth, which is a good fact, because without the atmosphere there would be no life on Earth. We wouldn't be on Earth. The blue, green and the vertical lines indicate the part of the spectrum that the human eyes use to perceive its surrounding. It can be seen that the energy of the spectrum is the strongest in that part. On this slide, you can see the definition of the theoretical borders of the visible part of the spectrum. I say theoretically because those are not strict borders, because we know that there are other colors of the rainbow in the visible spectrum. Other colors in the visible spectrum can be created by mixing the three basic colors: blue, green and red. And finally, let's take another look at the border between the part of the electromagnetic spectrum that is used in the form of reflected or emitted energy. It is at a wavelength of 3 micrometers. That would be all for this presentation. Thank you for attention and see you in the new presentation. Bye.